Welcome everyone to today's webinar, Teaching Predictive Modeling. The webinar is going to be delivered by my colleague Ross Matusalem. And a few things just to point out. One is there's a poll asking you about different software you use that you should see on your screen. We appreciate you answering that. We always like to see what software people are using, if it's JUMP or other tools. There is a Q&A panel, and so ask that if you have a question, type it into the Q&A window. I'm going to be here. My name is Kevin. I'm going to be answering questions along the way. I may occasionally ask Ross to stop to answer a question, and he may check in with me, but I'm going to do my best to answer all your questions by typing them in the Q&A window. So please put your questions there. There is also a chat window, and you're welcome to make a general comment there if you want, just some comment for the folks that are the attendees and us to see, but try to keep your questions to the Q&A. It's going to be a lot easier for me to manage them that way. With that, Ross, let me check in if you're ready to go.
Yeah, I'm here. Can you hear me okay?
Um,
All right, great. Well, let's do this. Thanks, Kevin. And thanks everyone for joining this tutorial on using JUMP software to teach predictive modeling. So in this hour, we're going to see in general how predictive modeling tools work in JUMP. We'll see a few specific tools in detail, and we'll also hear some advice for using these predictive modeling tools in a classroom setting. As you can see in my JUMP journal on the left, we're also going to talk about preparing for modeling. That'll just be a brief demonstration of a couple tools that you might use in a predictive modeling course or section to teach the precursor steps to actual model building. So things like screening for outliers or missing values. And at the end, as I often do in these teaching focused webinars, we'll review some teaching resources that you can get from us at JUMP that might be able to complement your course. I do want to point out that today I am using the JUMP Student Edition 18.2 specifically. This is a relatively new offering, so if you're not familiar with the JUMP Student Edition, this is free software for academic use, whether that's teaching, learning, or academic research at any degree granting institution. So if you want to teach predictive modeling or anything else with JUMP software and you're at a degree granting institution, you and your students can just go to jump.com/student to get the exact version of the software that you're seeing right now. And if you already have it, or if you do, go get it. Under the Analyze menu, you're going to find this predictive modeling submenu where the grand majority of the tools that we're going to see today live. And just by the length alone and noting some of the names of these individual tools, you can see that the Student Edition has pretty robust predictive modeling capabilities. And in this 1 hour, of course, we're not going to be able to look at every single one in detail. We'll look, as I mentioned, at just a few tools, a few foundational types of models in detail. But really, one of my main goals for you today is to build a mental model of how predictive modeling and the predictive modeling workflow works in JUMP that you can then use to teach any one of these types of models, regardless of whether we see it in detail today or not. And then the last thing I'll say is that, of course, because we're talking about teaching predictive modeling, I'm going to assume that if you're here, you already know the basics. So I'm not going to explain what a neural network is or how cross-validation works or classification versus regression models or things like that. The focus really is on enabling instructors to use these tools effectively in the classroom. So with all that said, let's start actually with a data set and building a predictive model in just a couple minutes to give you an idea both of what we're actually going to see in detail today, but hopefully also to demonstrate to you how easy JUMP makes predictive modeling, even with advanced methods. Thanks to its streamlined interface that doesn't require any code, you can really do a lot with predictive modeling with students of all skill levels and backgrounds. Now, I just brought up a data table. This is the data table we're going to look at today. It's actually bundled in JUMP in the sample index, which you can find under the help menu. We'll talk a little bit more about finding sample data at the end. This is the home equity loan data set. So we have information on just under 6,000 home equity loans. our crucial response variable here is whether or not somebody defaulted on that loan. So here we go, looking at all the values for yes. You can see there are just under 1,200 of them. These are the folks that actually failed to pay back the full value of their home equity loan. We also have information on each loan, like the loan amount that was issued. We also have information on the borrowers, like the number of delinquent lines of credit that they currently have. So they're behind on their minimum monthly payments, or that person's debt to income ratio at the time they applied for the loan. So the goal with this data set is to build a predictive model that for new loan applications can assign a probability of default so that a lender can make better lending decisions. All right, so we have the background. Like I said, let's just build a predictive model quickly now to give you an idea of how predictive modeling works in JUMP. So don't worry about the details right now. We're going to walk back through everything in detail in just a moment. But just to demonstrate, I'm going to go to Analyze Predictive Modeling, and let's start at the top of the menu. I want to build a neural network model to predict home loan defaults. So I'll say that default is what I want to predict. I have these 12 predictors that I can provide. And as we'll see, JUMP also can automatically perform cross-validation for us if we tell it what data belong in, training and validation sets. And so I'll do that as well. I click OK and get a control window out that allows me to, in this instance, specify some of the neural network structure. So I could change, let's say, the number and types of nodes in each layer in the network. For now, I'm just going to stick with the defaults and click Go. JUMP has automatically fit a neural network model for me and provided cross-validation statistics. So in JUMP, one of the primary ones for a classification task like this is entropy R square. We can see, for example, in the training set, the entropy R square of about 0.51. And then if we go all the way to a final test set, a little bit lower at 0.47 approximately. So not evidence of strong overfitting here. So once I'm inside a model, I have our JUMP red triangle menus to request more outputs. So a standard output you might request when teaching classification models would be an ROC curve. So if I want to pull up any of these kinds of outputs, I just request them whenever it is I want them. And then when I'm finally ready to use the model, that is to generate new predictions with it, let's say for this data table of new loan applications, all I have to do is publish our model into a tool we'll take a look at towards the end called the Formula Depot. And inside the Formula Depot, I can now take my neural model that I built and point it at any data table. So I'll say the new loan applications and score those data with just a click. So here's the probability of default for 500 new applicants. I can even click up here in the top of the histogram to find those with particularly high default probabilities, over 0.9 in this case. So there you have it. I just took a data set, built a neural network, was able to explore the cross-validation performance, look at some graphs, and then publish and use that model with just a few clicks. And that's the basic predictive modeling workflow that we're going to walk back through in detail. And again, I think the real power of this is just how easy it is, how streamlined the process is, so that students, when they're learning predictive modeling techniques, they can really focus on the concepts and the best practices without then getting bogged down in implementation or writing code. So that's where we're headed. Let me close this stuff up and then give you a brief summary of the predictive modeling capabilities in the JUMP Student Edition. I'm not going to talk about all of them at length here, but I have provided in this JUMP journal a link to jump.com where it summarizes the primary predictive modeling capabilities. So you all, after this webinar, will get a link to a recording and also this journal so that you can just click this link that I just did and land on this page, where you will have predictive modeling capabilities categorized by, regression, tree-based methods, other methods, and so forth. So I'm not going to read through this right now. You can go ahead and check it out on your own time. And when you do, you're probably going to notice that some of these things, for example, boosted trees, have a little pro icon next to them. That indicates that standard JUMP does not have this feature, but JUMP Pro and, thankfully, the JUMP Student Edition both do. So even though you see these little pro icons, if you're using the JUMP Student Edition, you have every feature that you're going to see in this list. And if you'd rather just look at a shorter list where I've pulled out, I think, the most prominent features, you can go ahead and look in the journal. So let me pull up this list of what I believe to be the most common types of models that might be taught in a predictive modeling course. I'm not going to read through them now, but go ahead and browse them. And as you do, I'll just mention that two of them at the bottom there, you're going to see XGBoost or extreme gradient boosting, and also Torch deep learning for things like image classification, among other applications, are both available via add-in. So an add-in is a bundle of code that you can install into JMP that extends its capabilities. So once you install one or more add-ins, you'll have an add-in menu. You can see I have a good number of add-ins, including one for Torch Deep Learning and another for XGBoost. So if you'd like to teach those techniques, click one of the links from this journal, and it'll take you directly to the page to download the add-in. So here we go. We're at the JMP Marketplace where you can download the free Torch Deep Learning add-in. You can watch a video and learn more about how to use it. All you do is click this download button. You'll download a .jmp add-in file. Double-click that file. JMP will open it and ask if you want to install. You click yes, and then you'll have those additional capabilities in your add-ins menu here. And I hope at the end to be able to do a quick demonstration of Torch Deep Learning specifically, as long as I don't get too bogged down here. You also might be interested in the related capabilities. Again, not reading through all these, but things like cross-validation, model comparison, exporting scoring code. This, again, is just a summarized list of what I believe to be the most relevant capabilities from that web page there. So that's all I'll say about the JMP Student Edition capabilities, other than to, again, summarize, in the area of predictive modeling, they're quite robust. I mean, you really can teach an in-depth predictive modeling course touching on many advanced methods, all within the JMP Student Edition here. So with that, now let's actually start looking at the JMP tools. I think you need to know to do this in the classroom, providing some teaching tips along the way. We'll bring back our home equity loan data set and get started not with building models. Let's actually talk about preparing for modeling. So, I think we would always advise students or practitioners, don't get a data set and immediately just start building models. You need to get to know your data first. Now, we have in our JMP academic webinar library a lot of learning content on exploratory tools. So things like the distribution platform for just visualizing and analyzing each individual variable, or Graph Builder for graphically exploring relationships between variables. I don't want to go over those in detail or really at all right now, just so that we can save time for all the predictive modeling stuff. But go ahead to our JMP academic webinar library at jmp.com/webinar, and you can find webinars that explain those tools. Instead, what I want to do is talk about two tools that really are, I think, core to preparing for modeling like this and that aren't covered in great detail elsewhere. And the first live under the screening submenu under Analyze here. And at the top, you're going to find two tools that I think are pretty important in this context: Explore Outliers and Explore Missing Values. So both of these are for screening data integrity. Let's just take a look at Explore Missing Values here. And before we do, actually, I'll just point out, why I'm doing that is we can see a good number of missing values. For example, these three rows for the number of years on the job of the applicant have these little dots indicating that those are missing. And there's actually missingness all over this sample data set. So it's something we would want to get a handle on before building any models. So let's pull up Explore Missing Values. I'll take my 12 predictors, put them in the Y columns row, and click OK. Let me close the commands right now. Actually, we'll move this over here and show you the basic output, which I think just this simple table to the right summarizing missing values can be pretty useful. So we can see, for example, in the loan column, and you'll notice when I click on loan in the table, the corresponding column is selected in the data table. We see that the number of missing values is 0. So that's good. We've issued home loans. We better know how much money we loaned each person. But if we go to, let's say, mortgage due, I can see we have 518 missing values. And if I want to find those, all I have to do is click Select Rows, and then those are selected in the data table. A little trick that even some seasoned JUMP users don't know, back in the data table, right here where it says selected, so this is the number of selected rows, 518, you can right click and go to data view to pull those out as a subset. And so I can further inspect these 518 rows, maybe perform some additional analyses to try to understand the features or characteristics of those loans for which we didn't have a mortgage due. In this case, we might imagine that actually it's because somebody didn't have an outstanding mortgage principal on their home, and maybe we would fill in a value of 0 for all these. So I could go through and actually explore the missing values for all of these different columns before getting started, decide what to do with them. For example, maybe I want to exclude them. But under commands, we'll find even more. So let's say I wanted to perform data imputation. Common thing in predictive modeling. Well, I have options for data imputation. In fact, right here, I fed in 2 categorical predictors. So this is my one option for data imputation. If I pull explore missing values back up, and let's say that I only use the continuous predictors, you'll notice that you get some other options as well. And this might be the one that's most relevant in a classroom context. So just the multivariate normal imputation. It's using, the correlations between these variables, least squares predictions to actually fill in those missing values. And finally, I might even look for patterns in the missing values by doing missing value clustering. So here, each horizontal row in this dendrogram represents one row that have been clustered together based on their patterns in what values for those rows happen to be missing versus not. We've also clustered the columns by patterns of missingness. And so I immediately notice this big square of black missing values right here, and I could click in the dendrogram to highlight those. So if we go back to our data table, that's 222 observations that all are missing in these selected columns. So I'll actually pull up those selections back in our data table here, and that's the number of derogatory lines on their credit report, the number of delinquent credit lines open, credit line age, number of recent inquiries, and the age of their oldest credit line. Or no, the number, excuse me, not age, of their open credit lines. So this is their credit report information. If I pull up these 22 individuals, then it looks like we have 222 individuals where we didn't actually run their credit report. So an interesting find here in patterns of missingness that would be certainly applicable, something that would need to be solved before diving into any kind of predictive modeling here. But really the point here, is in part to show you this explore missing values. We're actually not going to spend time and explore outliers, though it has similar functionality, but for identifying and dealing with outliers. And both of these tools can really be helpful for teaching some of the data integrity checks, data screening before actually getting started with modeling. Now, another thing that's common in a predictive modeling course is teaching about feature engineering. So that is using the existing variables to derive new variables or new predictors that might improve the performance of the model. And JUMP has robust capabilities for doing that through its formula editing options. So if you're familiar with something like Excel and you know about Excel formulas, JUMP has similar functionality. So let's take a quick look. Let's say that we have, of course, here the amount of the loan, and we also have the assessed value of the home that loan is taken out against. A potential feature we would want to use in building a predictive model would be the ratio between the two. So what proportion of the current value of your home is now being issued in that loan? So I can create a new column. I'm just going to double click in a blank column header here, and then right click and go to formula and use JUMP's formula editor to declare this new feature. Now, I'm not going to do a full-blown tutorial on the formula editor right now. You can go to the JUMP user community at community.jump.com to find learning materials on this tool. But this one is as simple as just saying, I'm going to take the loan. So when I click there, it populates loan into the formula area, divided by value. And when I click OK, I now have that ratio right here. And we'll see in some cases where one of those values was missing, I end up with a missing value. And so I could type in a new name here, let's say loan to value, and move that on up. We'll do it right there. So you can use the formula editor for feature engineering, another important precursor step to model building. I will show you that there are actually, and here let me delete this, some built-in formulas that you can do with just a single click. So let's say I select loan and value and right-click. I have this new formula column option, and what that's going to allow me to do is choose from some pre-built formulas that I want to apply to these columns. In this case, I might go to combine and choose ratio. And now that's given me the loan to value ratio with the same formula that I just declared manually. But I didn't have to even go into the formula editor to do it. And that could be particularly useful for students. I mean, if you don't want to even bother with them trying to use the formula editor, a lot of very common formulas you would use for feature engineering are built in to this new formula column menu here. For example, if I wanted to log transform a heavily skewed variable, I could just choose to do that right here. So it's just a couple tips on feature engineering. I really think that automated formula writing could be quite useful in the classroom. So with that, let's actually move on now to, the bulk of the focus today, which is building predictive models. Like I said, if I go back to the Analyze menu here, we're not going to see all of the different predictive modeling platforms in the JUMP Student Edition today, but I'm going to show you the general workflow so that you can apply it even to tools that we don't see today, depending on what techniques you actually intend to teach. And I've broken that workflow down into 4 basic components that can just be applied over and over again. The first is actually preparing for model cross-validation. So if you notice in our data table here, I have this column. I used it in that neural network at the beginning. And this column for each row declares whether that row is in a training set, a validation set, or a test set. So like I said, I'm assuming that if you're here, you're familiar with at least the basics of cross-validation. But even if you are, you might be looking at that and saying, oh, okay, well, so we're doing some kind of validation, but we have 3 different groups of data. Whether we're talking about holdout validation or k-fold, you might be more used to 2, and you might even start by teaching just a basic 2-way split. I'm just going to try to say now why I have 3 here. In JUMP in general, the training set will be used to actually estimate model parameters. You can then use a validation set for hyperparameter tuning or model selection. So for example, in a decision tree, you need to decide how many splits the tree should have. JUMP will automatically choose the number of splits that maximizes performance on a validation set. And then because you use the training and validation sets both in some aspect of the model building process, we have a final test set that's held back to provide a totally unbiased estimate of model performance. So with that column established, we can then feed that column into JUMP's predictive modeling platforms, and it just knows what to do with it automatically. But before we do that, let's actually see how you create one of these validation columns. And that's using a tool in this predictive modeling menu near the bottom that says Make Validation Column. So when you launch this, you're going to first get a window that you can just click straight through. If you just want to apply completely or just total random assignment to training and validation or test sets, you don't need to worry about anything that you're seeing right here. But what I'm going to do actually is stratify my validation sets by the proportion of defaults. So if we go back in our data set, let me just take a quick look in the distribution platform. You'll see that we have just about 20% defaults across the whole data set. And so stratification in this case is allowing me to say, I want all of my cross-validation groups to maintain that same 20% of defaults. This is particularly useful if you have a classification problem with a relatively rare target class, or if you're doing a regression problem and you have, a long tail and you want to make sure to kind of sample out into that tail for each group, you could use some stratification. Crucially, you'll notice this dropdown in the bottom left. It defaults to Make Validation Column, and this is going to make a column for holdout validation, which is what I'm using here. If you're teaching k-fold cross-validation, you might want to make a k-fold validation column instead. And this is where you specify that that's what you want to do. Auto-validation, don't worry about it. It's a more advanced and newer technique that's probably not really being taught in your typical predictive modeling course as of yet. So I click OK. Thankfully, JMP describes exactly what it's doing here. So when it says stratified validation column, what exactly does that mean? And then I have the ability to specify how much data go in the training, validation, and test sets. So if you're just doing two sets, training and validation, you could just adjust the relative proportions here. You'll see the test set is set to 0 by default. As I said, I want to use a test set because in most of the models I'm going to build, the training will be used to estimate model parameters. The validation will be used for model selection or model tuning. And then the test set provides our final unbiased estimate of predictive performance. Lastly, we have these options down here. If you are using this with students, I have two recommendations. One, leave validation column as fixed. The formula option will actually declare a formula column that will, anytime that formula is run or executed, it will reassign rows to different sets. Probably not something you want to do in a classroom context because students with different cross-validation breakdowns will end up with different numerical results, and there will be a lot of confusion. Similarly, you can set a random seed here by putting any number that you want into the random seed field. This will ensure that the random assignment actually takes place the same way every time. You actually get the same cross-validation splits. So I recommend either providing a random seed, telling all students to use the same one before clicking go, or you can provide them with a data set that already has a validation column in them. You can see here when I clicked go, it created a second validation column that is different than the first one because I used a different random seed. But the basic idea is the same. I could then go building models, feeding this validation 2 column in as we go. Now, each modeling platform has its own specific way that it implements cross-validation depending on the model type and what let's say what hyperparameters are being optimized behind the scenes. We're not going to get into that right now, but it is important to know, especially if you're teaching with this. So when you get your hands on this journal, go ahead and click the validation methods documentation link, and you will go straight to the relevant page to learn more about how validation works in JMP modeling. And there are multiple pages. So go ahead and read this first page. Click through to the second page and you'll learn for each modeling platform the different types of cross-validation that are possible. And then if you click forward again, you'll learn the differences in how JMP handles k-fold versus holdback validation. Again, we're not going to review that right now, but if you're teaching with this, I think that's pretty important. So I wanted to make sure to include that link for you here. All right, once we've made our validation column, the next step is to launch whichever modeling platform it is that we want to use. So let's go back to the start where we saw that neural network, and we'll walk through this in a little more detail now. All right, I launched the neural platform. Aside from using linear models in FitModel for predictive modeling, JMP's predictive modeling platforms have a very similar launch dialog. You take your response variable, it can be categorical or continuous, put it into the Y role, select your predictors, put them in the X role, select that validation column that you just made and put it in the validation role. Often you're going to see one or more options in the bottom left here. We just talked about random seed. So some of these algorithms have stochastic components. For example, a random initialization of neural network weights. If you want your students to get the same numerical values that you do and the ones that you intend, let's say when you're going back and grading or anything like that, again, you want to make sure that that random seed is set appropriately. You'll also notice here we have an option, in this case for informative missing, which is a way to actually treat missingness of a value as information, as a predictor in the model. Now, you might not actually understand exactly how that works, or you might have questions about any of the other options that you're seeing in a launch dialog. For example, the frequency role. What is that? What does it really do? Every launch is going to have this help button. So if you click help, it's going to take you straight to the documentation to learn more about all of the options in that launch window. So for example, if you want to know how informative missing works, you're going to find that right here. You'll also find information on what is going to be the next step in our model building process, and that is using the model controls. So we actually saw this window earlier, the control panel for building out our neural network. And this documentation that we've just accessed includes that information as well. And I wanted to highlight that before we actually go ahead and use those model controls to build our model. So I'll click OK. So instead of JMP just building a neural network using some kind of defaults, it presents you with the controls to choose what type of model or what structure of network to build. So for the neural platform, we have the option of up to 2 layers of hidden nodes and 3 different activation functions here. So I'm going to just build what might end up being a slightly overfit model. Let's see, with just 2 layers, 6 total hidden nodes in each one, 2 of each activation function. Note that the neural platform, which I think almost everyone teaching predictive modeling would touch on eventually, does support boosted neural nets. Then we have some additional fitting options over here. A critical one, I think, that's important for avoiding local minima in your model fitting is to maybe increase the number of tours. So this is basically going to rerun the algorithm 5 times at 5 different random initializations, so that you avoid finding kind of a spurious model. But anyway, I'll click go. And now the model is fit. So this is where we were at the outset today. So again, because I provided a validation column, JMP automatically cross-validates the model. So in this case, the training set was used to estimate the weights in a neural network. The validation set was used to tune a hyperparameter. So in JMP, there is a regularization or a penalty parameter applied to the weights, and you can specify the nature of that penalty here. And JMP automatically optimizes that by choosing the value that maximizes performance on a validation set. Then finally, we have our test set, which provides, again, that unbiased estimate of model performance. And I'm seeing a little evidence of overfitting here. So for example, the entropy R-square is 0.63 on the training set, but down to 0.56 approximately on the test. You'll notice in classification context, you also get a confusion matrix. Note that these confusion matrices that are going to be produced by default assume a probability threshold of 0.5, just right down the middle. So it assigns a class based on whatever the dominant probability is. That's often not what we want to do in practice. And shortly here, we're going to take a look at a tool that allows you to explore different decision thresholds interactively. All right, so now that we've built the model, we get a standard report. We use the red triangle to request additional outputs. So as we did at the very start, I could go to the red triangle and request the ROC curve. So looking at the ROC curve for the test data, we see the area under that curve is 0.94. So we're not doing too bad. Pretty decent predictive performance despite perhaps a little evidence of overfitting. In the neural platform, you might also be interested in the diagram. So the diagram will help make a little more clear exactly what the neural network model looks like in the same type of diagrammatic representation we'd probably see in a textbook or lecture slides. And a number of other outputs as well. For example, if you want to look at a lift curve or a precision recall curve, or maybe we just want to actually see the estimates, that is the weights for the entire neural network corresponding to all those arrows in that diagram. Now we're going to take a look at some more red triangle options in just a moment, but I want to stop here to then just reiterate the basic workflow. So you create a validation column, fill out a basic launch dialog. You're then going to be presented with some kind of controls to build the model. And then once you're in the model report, you're going to get a standard output. And then you go to the red triangle, and living there are going to be all those standard outputs that you're going to want to check out with your students. So let's actually see what this looks like in a couple other platforms, just to generalize our knowledge of this workflow a little bit. So I'm going to go to the Analyze menu now. And instead of going to the neural platform, I'm going to go to Partition, which you might be curious what this is. This is just a reference to the recursive partitioning algorithm underlying decision trees, or what you might know as classification and regression trees. So the launch dialog looks an awful lot like that from the neural platform. We say default is our Y. We have these 12 predictors. Our validation column will go in the validation role. One thing that's nice here is by using the same validation column, that is the same training validation test splits, it makes the cross-validation metrics comparable across different model types. We're going to get to model comparison pretty soon here. We have our additional options down on the bottom left, like we did before. We have our help button to explore what all these options mean. And when we click OK, we get a control window for building the model. It looks very different here because a decision tree is very different from a neural network. So here I have the top of the tree where we can see the 80-20 split in our entire data set. And I can click split to find the first split in that tree. It's actually at debt to income ratio at a threshold of about 43.7. And it looks like if you're greater than or equal to that threshold now, we would predict a default probability of nearly 0.63. And all along, we're getting our cross-validation performance as well here. So we can continue to split the tree or just click go, and JMP will continue splitting the tree until validation performance levels off. And it leveled off at an entropy R-square of 0.417. Performance on the final test set, a little higher than that, but marginally so, 0.458. All right, so we have our default output. Then I can go and request additional things. Like, for example, the neural net, I wanted to pull up the diagram to show students some kind of diagrammatic representation of the model we built. Well, we can do the same thing here by pulling up either the full tree view. So if I go to show tree, we'll see the full tree, which is a bit hard to digest when it's this large. So let me take that away and instead point you to the small tree view, which is a little more digestible. So we're saying we started at the top, we split on debt to income ratio at these thresholds. And then let's say we ended up on the left. The next thing we split on was the number of delinquent credit lines at these thresholds. This small tree view is, when you start getting to bigger trees, I think a total necessity so that you can actually still see the whole model. But then, of course, we have the other outputs we might want. For example, we can now look at the ROC curve for this particular model, and it looks like we're not performing quite as well as we were with the neural network. So we could keep going. For the sake of time, I'm not going to. But each one of these tools, you're going to find a similar workflow and interface. So you feed it the same validation column. When you launch the modeling platform, then you get the model building controls and then the model report with the red triangle options. So what I'm going to do now is actually highlight for you some tools that I think are really important not to miss. So those may be beyond the standard ones that you might see referenced in a textbook that you're using, for example. I'm just looking for my neural network here. Let's see. There we go. All right, so here's that neural network that I built just a few moments ago. If you're a longtime JMP user, you're probably familiar with our prediction profiler. But if not, anytime you build a model in JMP, you can go to the red triangle and request the profiler. And in this case, well, actually here, sorry, I meant to, because this is a classification task, you might want to request the categorical profiler, but they're fundamentally the same thing. This is an interactive visual representation of the model that I built. So I have one graph for each one of my predictors, so loan, mortgage due, value, and so forth. I have their current value in red, and then I have the predicted probability of default on the left here. So I can use this to explore the model. For example, I see a big effect of the number of derogatory lines on their credit report, a big positive one, meaning that as I drag this to the right and increase the number of derogatory lines, the predicted probability rises pretty rapidly. And we can actually see the relative complexity of all of these different effects. I mean, we see a lot of interesting smooth curvature in all of these. Now, compare that with, I'm going to pull up just a model that I've already built. This is a bootstrap forest. You might also know it as a random forest model. And here I have the same profiler already pulled up, and you can see the nature of the effects look quite different. For example, here's the effect for the number of derogatory lines on the credit report, and it's really a step function. And that's because this is a tree-based method, and we know decision trees are fundamentally just step functions. So I think looking at these different profilers can help students understand visually what types of effects or relationships the model's picked up on, but also by looking at the different shapes in these traces, start to understand fundamentally what makes these models different. Just to highlight another example, look at the effect for number of delinquent credit lines in the neural net on the left versus that bootstrap forest on the right. They're both finding something similar, right? That as you start to go up from 0 to 5, you start to see a rapid increase in default probability before leveling off after 5. They both found that. But whereas a neural network models this as this smooth, slightly curved increase, the bootstrap forest models it really as a complex step function. And so we can use these visuals to help boost students' intuition about exactly how these models are capturing relationships under the hood. And along those lines, don't miss the surface plot, which is essentially a 3D representation akin to this profiler. So in the neural network, if I go to the red triangle, I can choose surface profiler. And here we can see, sorry, this default yes looks like it glitched out on me a little bit. We can see a three-dimensional representation of this response surface. So for these two predictors, loan and mortgage due, we can see the effect that is in terms of rising probability of default on the y-axis here. And that'll look very different than 3D surface for a bootstrap forest. You'll notice in some of these modeling tools that the surface profiler is not available by default, but let me just show you, because I think it's important for teaching, how you can pull up a surface plot for any model that you build, even if it's not under the red triangle. So I'm going to save a prediction formula for this bootstrap forest back to my data table. And so it's writing the formula right now. I'll give it a moment to spin. Okay, so this column right here, this is a new column that actually contains, I'm not going to pull it up, you can see the check mark, a formula implementing this bootstrap forest model that we built. And now under the graph menu, we can go to surface plot and give it that formula column. And when we click OK, we now get a surface plot of this bootstrap forest model, which looks very different than the neural network one. Just another way to highlight to students in a more visual and intuitive way how these models can be drastically different in the way that they're actually capturing relationships between predictors and response. So you're going to get all of these materials again after the webinar, and I'll point you to this spot in the JMP data table where I dropped a number of surface plots for you to have a look at. For example, here's one from a lasso regression, so a logistic regression. And you can see, again, the surface looks an awful lot different here than it did in a neural net or a bootstrap forest, for example. Now, finally, last thing not to miss, I've alluded to this already, and that is the tool for exploring decision thresholds. So whenever you build a classification model using these tools, you're going to see this decision threshold option under the red triangle. So let's go ahead. You'll get decision thresholds based on your cross-validation splits, training, validation, or test. Let me pop open the test. Now, this is a pretty full-featured tool, so I'm not going to walk through all of it, but I'm going to explain the basics and I think everything you would need to know to use this in a basic way with your students. This is a representation of all the data in the test set. Up here, we have all of the defaulted loans in that test set. And below that, all the non-defaulted loans. We have the predicted probability of default from the model on the x-axis here. And so here, these are applicants for whom we would predict a high probability of default, and they did default. So this would be correct classification. Whereas down here, these are false negatives, people who defaulted that we didn't predict would have defaulted. And then we have the inverse on the bottom with the no's. So these are correct, and these are incorrect. And this is at a probability threshold of 0.5, the same that's being used to calculate these confusion matrices here. And you're actually going to notice that the values that you see right here are exactly the same as the values that you see right here. But what I can do is interactively change the decision threshold, let's say decreasing it in this case, because I want to avoid issuing loans to people who are going to default, maybe even at the cost of not loaning money to a few people who wouldn't have. And I can drop it down to, let's say, you know, about 0.25 or so. I could even type that in right here, 0.25. And now I can see the updated confusion matrix and misclassification rate. So it looks like my false positive rate is down to 0.08, but my false negative, the really bad one, is down to 0.13. And so maybe this is actually a better threshold for loan decisions than the original 0.5 was. Now, you may, if you're teaching classification modeling, use additional metrics. For example, sensitivity and specificity. You're going to find all those down here, and those all update in real time too as I change this decision threshold interactively. And helpful for students as they're exploring these different performance metrics is that you have definitions of all of them to the right here. So for teaching classification modeling, I think the decision threshold tool is a great way. I mean, there's a little bit to digest at the start, but once you get the hang of it, especially just focusing on, say, the confusion matrix, it can be a pretty powerful tool for demonstrating to students how important it is to set that decision threshold appropriately. All right, so that's building and using these predictive model reports. Remember this basic 4-step workflow? You can apply it to neural and partition like we saw and any of these others as well. And then, of course, under the red triangle, you're going to find those standard outputs that I know in a predictive modeling course you're going to want to teach, like those ROC curves in this context. But you're going to not want to miss these other tools that I just pointed out, the prediction profiler, the surface plot, and the decision threshold tool. All right, so I see we have 14 minutes left. I'm going to just continue on right now and then hopefully have time to take some questions at the end or during overtime. But I don't want to short our treatment of model comparison and deployment tools and also talking about teaching resources and hopefully getting to a quick torch example as well. So I've built a few different models right now, and actually in our data set, I've embedded some scripts for some others as well. So you can click this green button for a lasso model. As we saw, you can click this green button for the bootstrap forest model. As I showed at the outset, when it comes time to use these models outside of the tool that you built them in, I recommend using that Formula Depot tool. So the next step really in a modeling exercise is to publish your models to the Formula Depot. Under the red triangle, you're typically going to find that either at the top level or under a Save Columns submenu. So I can go to Publish Prediction Formula, and now I have a new Formula Depot that contains the formula for that bootstrap forest model that I've built. You'll notice, let's say I pull that neural net back up. So here's one of the neural nets that I've built today. If I choose to, I want to choose the red triangle next to the model itself. If I choose to publish that prediction formula, I now have multiple models living in this Formula Depot. So let me actually pull up a Formula Depot that has all 4 models that also appear right here in our data table. So I've fit 4 different models, and I want to determine which one has the best performance to know which one to use. Now, there are standalone tools for model comparison living right here. The workflow, I think, for using them is a little more complicated. So for using this with students, I recommend just having students publish their models to the Formula Depot, then going to the red triangle and choosing model comparison. You select the models that you want to compare and click OK. JMP thankfully notes, hey, you used the validation column for all of these models. Do you want to actually break out performance based on those cross-validation splits? And I will say yes. So now JMP is using each one of these models to compute performance for the training, validation, and test sets, and we summarize them down here. Now, this to me is a big table to ask students to grapple with it first. So a tip for you is to use the local data filter here, filter on your validation column, and then maybe select just the test set. Now it's a more digestible table, and we can find that if we're looking at entropy R square as our primary metric for classification, the best performance is in fact that bootstrap forest model. All right, so we've compared the models, we've selected the best one. Now we're going to use that model to score new observations. And we saw a quick demonstration of that before. So I'm going to pull up a table of our 500 new loan applications. And again, what we do is just simply go to the model that we want to score with and go to Run Script, point it at the jump data table, and click OK. And now we have the model predictions in that table. The one thing you're going to want to note is when it looks at that table to generate those predicted values, it's looking for columns that have the same names as the factors that were used to build the model. And so you want to make sure that your column names in this table to be scored are the same as those that you're seeing in the Formula Depot over here. All right, so we can use the Formula Depot for model comparison, model scoring. We can also use it if you want to get something, let's say like Python code or JavaScript code or SAS code for a model to be able to actually bring that model into another computing environment to continue to work with it, or maybe ensemble it with other models. This is starting to get to some stuff that'd be pretty advanced in a typical predictive modeling course, but maybe at the graduate level you would get there. You can just request that code and JUMP will generate it for you. And so here is the Python code, a really big set of if-then statements for an ensembled tree-based model right here. So that's the Formula Depot. It's one place to go for model comparison, model scoring, generating code. Real briefly here, just speaking of comparing models, here's a tool that I think might be useful once students have learned a certain subset of model types and they want to maybe apply all of them easily to some new problem. I'm thinking something along the lines of a final project or something like that. There's this tool under the predictive modeling menu called model screening. And we're not going to do a full demonstration of it right now, just for the sake of time. But what this allows you to do, well, I think I'm on my, let's see, yeah, I was on our new application table. So let's get back to our main table. I'm going to go to model screening. You say what your response is, you say what your factors are, you can give it your validation column. And then down here, you can choose how many or which models to run all at once. So each one that's selected will be fit using some kind of default hyperparameter settings. So let's just actually, I'll just do, let's say 3 of them right now, just to make sure it runs quickly. So I'll do a decision tree, that bootstrap forest, and a neural network. And when I click OK, JUMP calls out to each one of those platforms, fits a model, and then returns the results. And so if we look at performance, let's say on the test set, we can actually see the entropy R square value, highest again for bootstrap forest. And so this tells me that maybe what I want to do, if I go into the details, is explore this bootstrap forest model further. Perhaps actually, if we go down to redo here and go to relaunch, maybe going in and trying to tune some of these hyperparameters. Which, by the way, there are some good tools in JUMP for tuning hyperparameters, especially in these tree-based methods. You'll find them right here, and you can read more about them in the documentation. But just to back up, this model screening tool is a great place to go to, as the name suggests, screen a number of different types of models to decide which one you might want to use further. And I think this could really cut down on a workload for students in, again, like a final project where they're trying to apply and compare all of the different methods you've taught them throughout the entire semester. All right. I think we have a quick 2 minutes to take a look at this Torch Deep Learning add-in that I mentioned at the outset. So again, I've already downloaded it from that link I showed you before and installed it here. So this is bringing deep learning, so deep neural nets, to JUMP via the open source Torch package. One of the applications that's really quite amazing is using this for image classification. Now, if you weren't aware, JUMP can actually read images into data tables. So if you go to File, Open Multiple, and point JUMP at a directory of images, it will actually read them all into a data table. Now, this is an industrial example where we have metal castings, and what we're trying to do is develop a model that can take an image of a casting and tell you whether it has a surface defect. So for example, row 2 has a defect right here, row 3 has a defect right here, row 4 is actually looking okay. So what we can do is actually build an image classification model using Torch Deep Learning. I might set up validation using the built-in k-fold validation utility right here. I'm going to use the existing validation column in this example here and just launch the platform to show you that it works much the same way that all the other ones that I've shown you do. So I say what I want to predict. That's the class or the category. I want to predict it with an image. I'll give it my validation column and click OK. Deep learning involves a lot of hyperparameters. You have robust ability to change them here. I'm going to leave everything at the defaults, though, for now, and just click Go to show you again how easy it is in JUMP to be able to do kind of state-of-the-art deep learning here. So right now, over the course of maybe 20 seconds, JUMP is going to fit this deep learning model and return an interactive model report to us that's going to look and feel very familiar because it's actually drawing on this open source Torch package, but then translating everything back into a standard JUMP interface. So we have our cross-validation performance. Our validation accuracy, actually labeling these images, is quite amazing. We have interactive plots for finding, for example, let's say some of the rows that were actually not exhibiting a defect, but classified as such. So I could select those right here and have a look to see what might be tricking the algorithm. And more details on model performance below. We unfortunately don't have time to get deeper into Torch deep learning. If you're interested in this, we hope to have another academic webinar doing a deep dive on this pretty soon. So stay tuned on that. And so unfortunately, we didn't get to see the XGBoost add-in today, the other add-in that I mentioned. But if you're teaching extreme gradient boosting, the same basic logic applies here as well. So we're drawing on an open source package, but then translating it back into the JUMP interface. Now, finally, let's talk teaching resources. So in here, I have highlighted what I think are some places to go, things to know about finding resources for your course if you're going to teach predictive modeling with JUMP. The first is the books page. So at jump.com/books, you'll find a number of college-level textbooks that teach predictive modeling techniques with JUMP. You might want to go by course and, let's say, look at analytics and data science, which will zero in on some of the books that I would recommend. For example, Machine Learning for Business Analytics, if you're in that realm, Fundamentals of Predictive Analytics with JUMP, similarly. An older but still good book, Building Better Models with JUMP Pro. All of these teach the basics in an applied sense of your core predictive modeling techniques using JUMP examples throughout. If you need additional examples, I recommend going to our case study library at jump.com/cases. And again, you might sort our cases by application or by course. And you will find some, for example, here's one on customer churn. So we're actually predicting customer churn. I believe this is at a mobile phone company. So if you click through, you'll get the objective of the case study, the basic background, and then links to download a data set, and then also the case study PDF itself. And if you're not familiar with our case study library, these documents provide the full background and motivation for a particular task and then walk student through a multi-step solution path with explanations and JUMP screenshots and instructions along the way. And then finally, at the bottom, there will always be at least a few exercises for students to do for homework. So these are a great way to structure at-home activities. That is maybe as a precursor to an in-class hands-on exercise and a flipped classroom model. You can use these as basis for demonstration or lessons live with the students. You can have them work on the exercises at home or in groups. The case studies really have a lot of good use cases. And I've actually put direct links to 3 that I recommend for predictive modeling right here. Finally, I mentioned that we were using this equity data set in the sample index. I've listed a few more that you might want to use right here. So you can go into that sample index and just search for these names like bands data or diabetes to find them. And then for the sake of time, I guess I won't show it, but I'm hoping for a lot of you JMP users out there, you're aware of our learning library at jump.com/learn. If not, this contains a wide range of quick tutorials. So think like a 2-minute video on how to build a neural network in JMP. The whole idea is that these videos and the short PDFs that you'll find there will teach students how to use JMP so that you don't have to spend much class time on it. So go to jump.com/learn to get quick tutorials for all of the predictive modeling things that we've seen thus far today. Well, not Torch, but all the standard tools. And then finally, jump.com/teach. That's the one place, if you can only remember one URL, the one place to go to find everything I've just mentioned in terms of learning resources and a whole lot more as well.